All right, let's clarify what we're going to do for these activities that you're going to do next. We're going to go through all four of them. First thing we're going to do is activity D2, as described in the Canvas course, and that's to rent a server. We're going to rent that server from DigitalOcean. Note that you can also rent that from other cloud services like Amazon AWS services or Azure from Microsoft or Linode. Whatever works for you. But if you follow the instructions for D2, we'll be going through DigitalOcean. This will give us a server, and that server will be assigned an IP address. This is the number that represents to the world how you can talk to or address that server. It's basically its physical address in numerical form. The second step is to set up a web server. We're going to use Nginx on that server so that you can host HTML and other web content. So that's D3, activity D3. Then activity D4 is to buy a host name. I'm going to demonstrate how to buy that host name from Amazon Web Services using their Route 53. That's their DNS services. They are a host name registrar, which means they're authorized to sell host names. And that will be there on Amazon. Now you can also, the instructions in the course tell you how to buy it if you want to go through cheap names, but either way, though that host name has to be purchased independent of your server on DigitalOcean, because DigitalOcean doesn't have the ability to actually register host names. So once we've purchased our host name, then we're going to actually set up our DNS server, which does the mapping from whatever host name we buy to the actual IP address, so that when somebody goes in a browser and types in the host name, it gets translated because of that DNS server to those IP address numbers, and then that user is taken to your server. So once that's done, that will actually take us to the server. So that's step number 3, is buying the host name and mapping that host name to the IP address on our DNS server. Then the final thing we'll do is we'll go and get a certificate which allows us to have secure connections to this server. We're going to use a tool called Cert Bot, which is put out by a company called Let's Encrypt. It's a free foundation to actually encourage encryption of connections just out of the goodness of their heart, so that you can have a certificate that represents your server and tells the world that you are actually that person that you're proclaiming to be that host name. So that's the final step, is we'll get a certificate that allows us to do a secure connection to our server and allows people to safely go to your server. So those are the different steps. Number 1, rent the server. Number 2, set up the server with our web server software that will serve up HTML. Then we'll go and buy a host name. And then we'll, as part of that same activity, get our DNS mapped, so our IP address is mapped to our host name. And then we will finally get a certificate that allows us to have a secure connection to that server. So let's get started. First, activity D2, and after you watch this video, if you go through the actual course, you should be able to map these activities directly to what's actually in the Canvas course. So I've got my account here on DigitalOcean. You've got different projects. So I've got a project called CS260, and then you can just do a whole bunch of activities or services within that. So I've already got one, what they call a droplet. So this is my virtual server there created, and that's the one that I'm using for the course. So if you actually go look at that droplet and CS260, I've got basically our entire step here that we just defined. So I've got a secure connection going on there. And I've got it pointing to my droplet that you just saw there in DigitalOcean, and it's serving up HTML using the host name that I purchased through Amazon. So this is the finished project of what we're actually looking for. So if we go back here, I'll basically duplicate those same steps that I went through. So we're going to create a new droplet by just going up here to the create and create droplets. And I'm going to pick Ubuntu because all the instructions are for the distribution of Linux for Ubuntu specifically. There's a little bit kind of different syntax and things that the different distributions use. So make sure you choose Ubuntu so all of it matches. And then you're going to pick the plan that you want. So you can do the shared CPU. That's the cheapest one, as opposed to having resources specifically assigned to you. And then you're going to take it off the $40 a month plan and put it onto the $6 a month plan. And then you're going to drop the price even more by not using the premium unleaded. CPU, but actually using the Intel one. So that gets us down to $5 a month, or 0.7 of a cent per hour, giving us a gigabyte of RAM, one processing unit, 250 or 25 gigabytes of disk SSD, and a transfer, the bandwidth of one terabyte there. I don't want to add any extra storage. I want this thing to be allocated in New York and their third data center that they have in New York. I don't want any of these options. And then I want to secure it using SSH keys. Now this is a slight variation from what is actually given in the Canvas course. There they describe assigning a password and using it, but we can't, and then afterwards there's the optional activity to actually change it over to use SSH keys. But if you use SSH keys here, then you don't have to deal with the password at all, and you're already using a much more secure way of getting into your server. So I'm going to use SSH keys. So I've already got 3 different SSH keys here. I'm going to create a new one, and we're going to call this one DO for DigitalOcean. Now I have to actually put the content in here, which is the SSH key. Over here on the right, you can see they're actually describing to you all the steps to actually do this. So the first one is to use a tool called Ssh Key Gen, which should be available both on your whatever shell you're actually using, whether that's on Git Bash or iTerm or whatever. And I can come over here to so this is just my local computer, my terminal here, and these are where all my keys are, and I'm going to create a directory called DO. That's where I'm going to stick my keys. And I'm going to, make directory, DO, and I'm going to change into the DO directory. We're going to actually make this a bit bigger for you, so you can see everything that's going on there. And I see I've got this empty directory here in my present working directory. You can see under usersly, I just stick my keys in here, and I'm going to put this key in this DO directory. So now if I just type that command that they told me to do, which was the SSH Key Gen command, SSH-Key Gen, then it's going to create the key. It's going to ask me, the first thing is what do you want to call this thing? And it's going to stick it in this directory here if I don't give it a name. And I want it to go in the directory I'm in, so I'm going to just use the same name but not specify a directory. This is whether or not I want a passphrase to protect it, which is an additional level of security over it. So every time you use the key, you've got to give the passphrase. I'm not so concerned about protecting this thing in a very maximal way, and so I'm not going to use a passphrase. So I just push enter and enter again, and then there's no passphrase over it. And it creates my key. So I've got these guys here. If I actually do a less command on the ID RSA, this is my private key. And you can see it's just this big blob of base64 encoded data. This actually represents both the private and the public key in this one thing. So it's got all the information it needs to know. And if I go look at the other file, the public key, then you'll see there's also this encoded base64 representation of the key, which is the public key. And this is what we're going to give to DigitalOcean. So if I just copy this right now, paste it over here, and I missed the L. Make sure you copy the whole thing or it's not going to work. So I've got the first thing all the way down to the last thing. And just to make sure I got that right, I'm actually going to do a cat of the rsa.pub. And I'm going to pipe that. So I'm going to take the output of the cat utility and push it as the input into a Mac utility called pb paste. You don't actually have this if you're using, pb copy. If you're using Windows, they've got a similar kind of thing, but you have to look up what that actually is. So now I've got that in my clipboard. I can delete this and just make sure I get it right. Paste that in here, and yeah, I had an extra little thing on there that I copied. Oh, no, there it is, RSA. So we're good. So that's got there. It checks out. It thinks it's a good one. We're going to call it do, and we've got our SSH key in there. So we're good to go. We're going to use that one. We're going to use SSH keys for authentication. And we only want to create one droplet. I'm going to call this one our DO. Will be our host name for it, and that's what we'll use in our certificates and everything else and when we register. I don't want to enable backups because I don't want to pay for that service. That will take a copy of your droplet like every week and allow you to restore it if something goes wrong with your server. And I'm going to push create droplet. Okay, so that's off and building. What we really need is that IP address, which I've got here for my other server, so that we can do our next step in the process, which we've done this one right here. We've rented a server. And we need that IP address so that we can get in there and actually set up our web server. So we've got to wait for that to complete. Looks like it's going a little bit faster now. And I can copy that IP address. So this is the number which represents your server. So if I come over here and I actually use the SSH utility, type -I, and then give it my private key, and then say root, because that's the user that I'm SSHing into, shelling into the server as, and then paste that IP address on there. I'm saying I want to create a remote shell on this server represented as this user who is authenticated using this SSH key. And if everything goes well, it will ask me if I, so what this is doing here is it's saying there's a fingerprint for this server. And the very first time I go there, I want to save that fingerprint. So if I ever go there again and that fingerprint's different, I know I'm not actually talking to the server that I think I'm talking to. Even though its IP address is the same, something's gone haywire in the network connections and I'm not actually talking to who I am. So I'm going to say yes. I'm going to accept that fingerprint because I know it's the correct one this first time. And it permanently adds that, so it won't ask me again. And so now I'm actually on my server. You can see that it prints out some statistics and information about it, places you can get help. But basically, I'm just in this root directory. And if I do like who am I, you can see I'm the root user. If I do pwd, then I'm off from the root of the actual disk drive of the machine in the root users directory. That's great. Okay, so what's our next step? So we've got all that done. We just want to, as our next step, let's see, yeah. As our next step, we want to actually enable the firewall on the server, which means I'm protecting who can actually access this machine. And after that, I'll install Nginx and we'll be good to go. So what I'm going to do is I'm going to use a tool called UFW, which is the I always forget what the U is for. It's the uncomplicated. UFW is Uncomplicated Firewall. So I'm going to use this tool to see what it's currently set up as. So if I do Uncomplicated Firewall and what apps are accessible through it and do a list, you can see that it will allow open SSH in. So that's actually how I got in the very first time, is that the firewall is configured to let us come in on port 22. That's what SSH actually talks through and talk to it. So now I want to allow it I want to enable my firewall and still let SSH through there. So it's listed there as an available application, but we haven't actually enabled it yet. So I'm going to do UFW allow open SSH. Okay. And now if I do, and then I enable the firewall, UFW enable. It's giving me this warning. It's like, hey, if you're on an SSH connection and you're actually disabling SSH, then you won't be able to get in the machine again, which would be really bad. What I'm actually doing, though, is enabling the firewall specifically so I can use SSH and only SSH with the server. So I'm going to go ahead and say yes. And now if I show my status again, then it shows that SSH is allowed in both on IP addresses v4 and v6, and you can come to them from anywhere as long as you're basically talking on port 22, which is that OpenSSH port. So I'm good there now. So I can actually like exit out again and come back again, and I won't be able to access my server on any other port, but I will be able to do it on this one here. So what are the commands that I did? I got the status of the firewall, I enabled the firewall, and I allowed it to use OpenSSH through the firewall. So the firewall, the whole point of that thing is just to protect the server and only allow certain things to happen on it. In this case, it's the kinds of applications that can allow access to the server. And the one we really want first is SSH, and then the other one we want is the web server to be able to talk over the network. So just those two are the ones that we're going to enable through our firewall. All right. Now we want to install our Nginx server. So what we're going to do that is we're going to use apt-get, which is just a package manager. It's basically, you can think of it as installs applications on your server. And we're going to, first thing we're going to do is update it to make sure it's got the latest definitions of all the applications that we could install on it. So I did an apt-get upstate. And it's going out there and it's saying, hey, do I got everything that's latest? And it's going to go grab a couple extra things, and now I'm good. And then I can use apt-get. So this is install this application using the install command. And the application I want to install is called Nginx. That's our web server. And it's saying, hey, I'm going to install 8 megabytes there of data. Say, yeah, go for it. Looks good. It'll actually install Nginx for me. Great. And now what I need to do is make sure that in the Nginx, the web server, can actually get through my firewall so people can talk to it. So let's do our UFW apt list again. And you notice I've got a couple new entries in here. I've got this Nginx entry. It's because when Nginx installed, it made itself known to the firewall application and said, hey, you can use me. And what we want to do is, so these are the 3 different ones. We can do it full, which means you can do it secure and non-secure, HTTP, which is non-secure, or HTTPS, which is secure. So I'm going to actually enable both. So I'm going to do UFW allow Nginx full. Go ahead and execute that. It says, okay, I'm going to add some rules for that. And so now if I do the UFW status, you'll see that not only do I have OpenSSH available, but I also have Nginx available. Okay, that sounds great. And then control. Last thing we need to do is actually start up the servers, which is Nginx. Okay, so that tells us, that doesn't actually start it, that just gets the status for it. So that allows us to know that it's actually running. So system control is the service background engine for the operating system, and it's running the service called Nginx and telling me that that thing is now running in the background. So we're good to go. You can use that same command to like stop it. So if you want to stop your web server, you can do that. And now if we do status again, you'll see that it's not running. And if we do it again with start, and then do our status again, you'll see it's running again. So we're all good there. Okay, so that is basically setting up the application web server there. We're all happy. We can go ahead and test that by pasting our IP address in here. Still got that here. So if I just hit that IP address, it should show me the web server showing up in Nginx, and that's our first step. So that takes us through, if we go back here, we've rented our web server and we've set up our web server. We're able to actually access it on our IP address and get the response because we've allowed the firewall to allow that access through there. So I don't like this page, it's really ugly. Let's go and fix it. So when Nginx installs, it installs things to var www. So if I change directory to there, then there's this default HTML. So if I cd into HTML, and I look, there's this default web page, this one right here, this Nginx debian.html. And if I do like a less on that, you'll see that this is the actual HTML that's being served up into here. And it's kind of ugly. Plus I want it to be different, so I'm going to use VI, and I'm going to edit this file right here. So don't care about the styles. So I'm going to delete these lines. Don't care about, we'll leave the title, but we want it to be different. So using the I key to insert, I'm going to change it to, you know, the DO demo. And then I come down here, and so that was just the title that I changed. So now I'm going to change the actual heading. That looks good. If you see this page, it is working. Awesome. Escape out of edit mode, hit DD a bunch of times, get rid of all this other junk, don't really care. Don't want to give credit to Nginx, my work, not theirs. Push this, and then I'm going to do WQ to actually save that out. All right, so if I go and refresh here, it's not going to actually work. Oh, it did work. That's so cool. Nginx is so smart. It actually detected that the file was changed. It didn't cache it, and we got our demo up and working. So there you go. So now we've completely completed that step of making sure it's all good in there. The next part is to actually go and set up the DNS. Now to do that, we've got to go and buy our hosting and then put it into our into our DNS server. And then once we're good there with that, we'll be all set to actually get our certificate, and we should be good. So I'm going to go to Amazon Web Services. If you just search for AWS, you should be able to create an account. It's pretty seamless to do. And once you're in there, the service that you want to use is called Route 53. That's all their DNS services. Go ahead and access that. Once you're in here, you'll need to actually go and purchase a domain. So under domains, registered domains, you can go here and say you want to register a domain, get a new one. And like I showed you, you can get all sorts of endings. The cheapest ones are .clicks. You can look through the list. There's ones that cost hundreds of dollars, but .clicks only cost $3, so it's 1 year, $3, good to go. And we can call it whatever we want, you know, so CS260 like I showed, and check that it's available. Looks like it's available, so we're going to add it to our cart. We're going to buy one of them for 1 year. If I buy it for 10 years, it's going to cost us $30. Probably only want it for 1 year. And then go ahead and continue, and that will actually buy the thing for you. And once you've bought it, I'm just going to cancel out of that. It will show up here under your registered domains, just like I have liasjensen.com. You know, cs260.click would actually be there. Then you can click on that, and you can come in here, and you'll see that this is all the information about the domain. And if I actually go to hosted zones, you'll see my Elias Jensen. If I click on that, then that will allow me to put in DNS records for it. So you see I've already got a few in here. I've got ones for my other Droplet information that I had before, right here, this one. So this server, the DNS information for that one is right here. So CS260 liasjensen.com is pointing to that Droplet server there. And then I do a wildcard one too, so that I can do like lab1, lab2, whatever, .cs260 liasjensen.com to that server also. So now I have to create a new record, which points to the one that we just created, this DO guy right here. So I'm going to push create record. I'm going to do a simple routing policy. There's lots of cool things that you can do, but we just want to do the simple thing. And I want this guy to be, when I go to do.liasjensen.com, I want it to actually hit my server. So I want what's called an A record, which is the most basic map a name to an IP address thing. And I want it to go to an IP address. And that IP address is the one that we had for our server right there, 157. So if I come back over here, it's 157, this one right here. And time to live is how long it's going to keep that thing in the system. So it propagates this mapping from the IP address to the hostname all over the world across lots and lots of servers. And every time it propagates it to it says, only remember this for a short amount of time. 300 seconds is a pretty typical kind of time. It's your time that it will remember that. So even if you wouldn't change what server is pointing to, it might not change immediately until all of that caching is purged. So I'm going to go ahead and define that simple record. And that looks good. So I'm going to go ahead and create that record. And now you'll see I've got a new one. do.leejensen.com is pointing to the IP address. And I'm going to create a second one, which is my wildcard one, which allows me to do subdomains off of my domain. I'm going to define another simple record. I'm going to do a star here instead of an actual, star.do, because we don't want it to confuse with my root, my Apex name, but star.do. It's going to route an A record. It's going to route to an IP address. It's going to be that same address that we just used. Same time to live. Life's good. And create that record too. So now I've got that one. I've got that one. I've got my DNS all set up. So as soon as that propagates, we're good to go. It should map the thing right over to it. So if I actually come back here again and do do.leesjensen.com, ta-da! I mean, I was already kind of there, so that wasn't very fun. But you can see that it does work. If I refresh it, it is actually showing me the same exact thing that I had there before. But now I'm actually using my DNS host name that I just bought. I own that thing. It's like mine. I can do cool things with it, show off to all my friends. But it's also showing me that it's not secure, and that's not good. And it's saying it's not secure because it doesn't have, because I'm going over an insecure protocol. I'm going over HTTP instead of HTTPS. S stands for secure. So it's Chrome's hiding that from me, but it's actually doing that when it actually makes the request. And if I tried to do the secure one, HTTPS, then I'm going to get an error because there isn't actually, it's not serving up that yet. So we'll stay on the insecure one. Okay, so that's setting up the DNS. We're all good there. So if we go back to our diagram, we purchased it through the Amazon Web Services Route 53 as the registrar. You can also use like cheap names and stuff. It's basically the same thing. But if you do that, then your DNS server will have to be done through DigitalOcean. And if you just go to DigitalOcean and go to their networking stuff, and then go to the domains, you can register those same those domain DNS records, the one for just the main one and then the star here. But you have to do this additional step of, so if I go in here, and I actually did it, so leesjensen.com, and add that domain. Wait for the fish to finish swimming. I can create those same records just like I did before, a record, and I can do my DO here and have that go to my IP address that's specified there. I don't want that really long, TTL, I want that to be smaller, and I can push create record. But this is missing one crucial part. So you are not having the part where this hostname register is connecting to this DNS server. It's not pointing the fact that it knows what that is to this guy here. And you hook that together by actually following the steps here of learn what to do, or look in the course, the Canvas course that actually steps through what you need to do to actually set that up. So we don't have to do that because we did everything over in Amazon, so we're all good there. I'm going to actually go back and delete that thing there because I'm not going to use it. And we're good. We bought our server. We set up the Nginx web server. We bought our host name. We mapped our IP address to our host name, and we're actually able to go get it using not that one, but this one, the do.leesjensen.com. And the final step that we need to do is actually get a certificate so that we can use HTTPS instead of the insecure connection protocol. And the reason I moved this activity up early is because security is paramount. Really, we should be talking a lot about security throughout this whole course because the web is a dangerous place, and you as a web programmer need to ensure the safety of those who are using your systems. If you're insecure, then basically all the traffic that goes across that. So if you have a password or something you send across it, that is totally visible to any server that passes through. So any bad actor can easily intercept that and gain access to all that data. So we want to always make sure that our communication is always encrypted whenever we send it from a browser to our server. So that's why I feel so passionate about having moving this A1 activity up here so that you can actually have that encryption protection in place. All right, so to do that, we're going to go back over here to our web server. Right now I'm in this HTTP directory, which is where my web pages are being displayed. I'm going to change back to my user directory using the tilde, just because I'm going to run some commands here. And I'm going to use what's called Cert Bot. Like I mentioned earlier, Cert Bot will allow us to hit Let's Encrypt, and that is what will generate, that service will generate our certificate for us. So in order to do it, we're going to use a different package manager, not the apt-get one that we used earlier. We're going to use one called Snap. And we're going to install the core functionality that allows Snap to act as a package server. So we're going to install that. It's going to take a little bit. And then once that's done, I'm going to tell Snap to refresh all of its core functionality. So that was basically the same thing we did apt-get when you did the update. Just make sure that all of its definitions of the applications that you can install with it are there in line. There's lots of package managers out there. These are just two of them that are used on Ubuntu. Okay, the next thing that we want to do is we want to use Snap, our package manager, to install an application, which is called, it's the classic version, and which is called Cert Bot. And this is just the utility that talks to Let's Encrypt through Nginx to say, hey, I'm on the server, which I'm asking a certificate for. You can hit it just like we were hitting it using the host name that we set up, and that will prove to you that I'm on the right server. And then you can actually generate me a certificate, and I'll register that with Nginx and the operating system so that I can do a secure connection. And this is really cool stuff. I'm going to go in a lot of detail of what that actually is all doing, like in the last couple weeks of the semester. Just know that it's giving you a certificate, and it's allowing you to make a secure connection. That's really all you have to worry about at this point. So I'm going to go ahead and hit that. This actually takes a little bit of time to do because it's actually communicating with the server. Oh, sorry, we're actually installing right now. We're not actually asking for the certificate yet. So I just installed Cert Bot. Then I actually want to ask for the certificate. So I'm going to use Cert Bot now to do Nginx. So I'm saying I've created a certificate using Nginx, and I want the domain that I'm actually creating it for to be Jensen.com. So create me a certificate, configure Nginx, and do that for this host name right here. And this is going to work because I'm on that server that's being hosted by that host name. So this will take a little bit of a while. It's going to ask, because it's the first time you've Cert Bot, for some information. What it's asking here is for an email address. So these certs only last for a little bit, and Let's Encrypt certs are very short. They're only like, I think 90 days is how long they're valid for. So it's going to renew them every 90 days. And if you forget to renew it, it wants an email address that it can hit and say, hey, your cert's about to expire, and therefore you won't be secure anymore, and all your users will get nasty security warning errors, which you don't want to happen. Now Cert Bot will be running here, and it'll run in the background to do the auto renew, which I'll demonstrate here in a minute. So you shouldn't ever get the email, but if it doesn't work, then it's good to have that email. So I'm going to say leasjensen@gmail.com. And it says, that's great. Have you read my terms and conditions? Oh yeah, I totally agree with all of them. Do you want to be part of their study? No. And now it's doing the whole handshaking, communicating, sending all sorts of stuff around. It said that it successfully got the certificate. Hooray! And it also says that it reconfigured my site, my Nginx default site, to properly support HTTPS. So that's it. That's what you had to do in order to actually get the certificate. So now if I come back over here, my insecure still works. Oh, but you can see that. When it hit Nginx, Nginx said, oh, now I'm actually configured to use secure HTTP. And so I'm going to prefer that. And so I actually switched automatically over to actually use my certificate. And so now if I click on this and I see what my certificate looks like, it says that it's valid. And you can see that I actually got that certificate, and everything looks great about it. Yeah, the details of it. It's always fun to go and see all the details. You can see that the organization who issued it was Let's Encrypt, and that's great. So now I'm good. I've got a secured website serving up content that I actually created myself. I own that server. I own the host name. we've completed everything that we wanted to do. We rented our server. We set up the web server, Nginx. We went and bought a host name. We mapped over our DNS so that our host name is pointing to our IP address. And then we got a secure certificate, which allows us to access that. Hope that makes sense, and sorry that I was so stumbling on that in class today. But if you have any other questions, hit us on Discord. We'll be happy to answer them for you.